I wanted to write a first example, first illustration of a computer program to solve a physics problem. In this case, it's really a pen and paper physics problem. We don't need a computer program to solve this problem, uh, but it'll introduce us to some of the components of Python programming. So in a Python program, in other computer programs, the program is a list of instructions. And we'll see as we write this program that you can execute those instructions, or the computer can execute those instructions one by one, or the computer can execute those instructions by running the entire code. And the example problem that we're going to work on is of a falling body, a dropped body. And we're going to apply the free fall law, Galileo's free fall law, to the drop body. And we're going to calculate the distance it falls in a certain elapsed time. And so we're actually going to input the time it has been falling for, and the computer is going to calculate the distance that it has fallen during that time. And this little program is just a few lines of code. Is going to introduce us to variables in Python, assignments in Python, arithmetic in Python, and input and output in Python. So it's going to get us started in Python. So for the first line of the code, I'm going to assign the variable g to the numerical value of 9.8. So in physics, we deal with physical quantities, which we represent by numbers, which we represent by vectors, or more complicated quantities. And so G equals 9.8 is an example, is an illustration of a physical quantity with an associated number and a associated variable. G equals 9.8 is a assignment statement. So the way to think of this assignment statement is that in Python, imagine there's a little box that's going to store the value 9.8, and that box is associated with the variable g. And so that's kind of the assignment statement, that there's a variable g that has the value 9.8. Now, in Python, there are various types of variables. So one type of variable is an integer, like 1 or 2. Another type of variable is a floating point variable, a float, 3.14, 9.8 are examples. And then another variable type is what we call a string. So a string is just a sequence of characters. They can be alphabetical characters, they can be numerical characters, they can be an underscore, for example. That would be a string. In the computer, integers, floats, strings are stored differently in the memory, and they take different numbers of bytes to store them in the memory. In the computer, for example, integer arithmetic is generally faster than floating point arithmetic. In the computer, integer calculations are generally more exact than floating point calculations. So in your physics problem, if you've got an integer, you probably want to use an integer type in your Python code for that integer variable. because it's going to be quicker to do calculations. They're going to be more exact when you do the calculations. Here we got a floating point type. So we're going to use a floating point variable for this quantity, this variable. Now Python automatically associates the variable as being an integer or a float or a string by your assignment statement. So when we run this assignment statement, I'm going to type shift return to run it. It actually assigns G to be a floating point variable because the quantity on the right, 9.8, is a floating point number. If we want, we can check that assignment. In Python, there's a function called type that will tell you the type of variable that, for example, G is. So if I enter type with an argument that is the variable G, and then execute this statement, it tells me it's a floating point variable. If I had defined G as 10 rather than 9.8 and made the assignment of G to 10, then it would tell me that the type of G, the variable type of G, is an integer. If I had defined G as a string 10, then it would tell me that the type of variable is a string. And so that's an example of an assignment statement. Anyway, we want 9.8. Let me make a final comment about this assignment statement. The assignment statement had some white space. Here's a white space, and here's another white space, and that's optional. We often add white space for the purpose of clarity, for the purpose of easy reading, for the purpose of style. But that white space does not have a meaning to Python, is not treated by Python in general. Another comment. I called the acceleration of gravity, I called that quantity, called that variable G. If this was a more complicated program, a more complicated calculation, I might want to be more explicit, more careful, more thorough about my names of variables. I might have called this gravity to make it clear what the meaning is, to make it clear what the variable represents. In a short program, in a few line program, it doesn't really matter. Okay, so at this point I've assigned the variable G to 9.8 meters per second squared. The next thing I want to do is input the time the object's falling for. And I'm going to use the Python input statement for that. And the Python input statement really does two things. Firstly, it prints out some text to the user to prompt the user, me, to enter the time. And then it receives the text that I input and sets a variable equal to that inputted text. And so here's my input statement using the input function. The argument of the input function is the text that the function will write out to prompt the user. And the result of the input function is the string that the user enters in response to the input function. And we're going to assign that to the variable t representing the time. So let's execute this statement. So again, there's two things going to happen here. It's prompting me for the time, 2.5 seconds. Press return, and it's assigned t to be that 2.5 that I entered. Now, there's a very important point, very key point about the input statement and this assignment to the variable t. If I look at the type of variable that t is, it's a string. So input, when it inputs something from the user, when it inputs some text from the user, it always inputs that text as if it was a string. And we actually want the time to not be a string. We want the time to be a floating point variable, like G was assigned to be a floating point variable. And so the way to handle that is to, with the float function, turn the inputted string into a floating point variable. And so you see now I've enclosed the input statement in this, this float function, which will create a floating point variable and assign t to be that floating point variable. So let's execute this again. And a 2.5 again. And now let's see what type of variable we have for t. And now it's a float. So that's a very important thing to remember about the input statement. It will assign your nth quantity to be a string, and you can change that with a float statement to be a floating point number. You can change it with a int statement to make it a integer variable. The next thing that we want to do in our code is some basic arithmetic based on the free fall law, based on Galileo's free fall law. So we want to calculate the distance, vertical distance fallen. I'll call that y. And we're going to make that calculation with a arithmetic statement. So in physics, we're often doing basic maths. We're doing addition, we're doing subtraction, we're doing multiplication, we're doing division, we're raising things to powers. All those operations, the addition, subtraction, multiplication, division, are operations we can do in Python. And in this case, our calculation for the distance fallen is that it's half the acceleration times the square of the time. So let's just enter that. Half the acceleration times the square of the time. And so this is a Python statement for that operation. The asterisk here is our multiplication. The pair of asterisks is as raising to the power. If we wanted to do addition, we'd have a plus operation. If we wanted to do subtraction, we'd have a minus sign operation. And then we can execute this statement. And so that has now assigned the variable y. It's another assignment statement to this quantity on the right-hand side, which involves two other variables, the acceleration of gravity, g, the time fallen to t, according to this mathematical operation. Again, we can check the type of variable of y with the type statement. And it too is a float. It's a float because the arguments on the right-hand side of that arithmetic equation were floats. So in Python, if the arguments on the right-hand side of the equation had all been integers, then the result would in general be an integer. If the arguments on the right-hand side of the equal sign had all been floating point, in general, they'd all be, the answer would be, the assignment would be a floating point variable. If the arguments on the right-hand side of the equal sign had all been complex numbers, then the assigned variable would be a complex number. So that's one rule about types in Python. Now, supposing you had a mix. So supposing you had a mix of variables that were, say, floating point and integer variables. Then the assigned variable is the more general variable. That would be a floating point variable. If you had a mix of complex variables on the right-hand side and real variables, then the assigned variable would be the more general one. It would be a complex variable. Let me show you that. So in this equation, y is defined in terms of both floating point quantities, g and t, and integer quantities that divide by 2. So if we execute this and look at the type, it's floating point. It involved both floating point and integers, but the type of variable is the more general type. Again, in a arithmetic statement like this, white space is optional. We could remove this white space. Python would treat the equation the same. We could add more white space if we thought that made things clearer. Python would treat the statement the same. And so you can use white space in general to make your code more readable, more kind of friendly. But now we've calculated the distance fallen, all we need to do is output the result. And to output the result, we're just going to use the print statement. And so I'm just going to print out the resulting value of y. And so let's execute that. And we find that the object fell in the 2.5 seconds, 30.6 meters. And so this little code is just 4 lines, but it introduces us to variables in Python, integer, floating point, complex, etc., strings. It introduces us to assignment statements in Python. G equals 9.8 is an assignment statement. T equals the right-hand side here is an assignment statement. Y equals the arithmetic right-hand side here. That's an assignment statement. And it introduces us to the input quantities with the input statement, the output of quantities with the print statement. Now, the print statement, we could add more arguments to the print statement, add more quantities to the print statement to make the result of the program, to make the output of the program clearer. For example, I could add in a string separated with a comma to indicate that that value that got printed out is that distance y. I could add in a further string to remind us that the time taken in this particular calculation was t. And so print statements allow you to print out a whole list of things, a whole number of things. They can be variables, or they can be strings.